Hello, everyone who's already joined. Welcome back. It's been a couple of weeks since our last Sui Educate session. So hopefully Shayan is ready and raring to go. Oh, I see that he's joined.
Shayan is ready and
Hello.
raring to go.
Amazing. How has your week been?
It's just started pretty much. Like I just got back from Denver, so there's like some like inertia, but it's going well. It's
Yes,
going well.
the same for me as well. Just back from Denver, which was crazy, but had a great time there. And I guess everyone is ready to get stuck back in again. I hope.
Oh yeah, and also I just wanted to say before we do get started, today, March 8th, is International Women's Day. So I wanted to say just happy International Women's Day to everyone, all the women especially out there. You guys are our mothers, sisters, daughters, cousins, aunts, and I guess I'm forgetting some, but nevertheless, thank you all for being with us. Like you guys definitely make life much more beautiful, and like even in my professional career, I'm so happy to be able to like work with so many amazing women. So thank you for existing. And yeah, with that said, let's jump right into it. So as you guys might be able to tell, today's presentation is an intro to dynamic fields. Or at least I've hinted about dynamic fields like several times throughout, especially not last week's, but the previous session. So now we'll really jump into what dynamic fields are, what they do, and how I think they can really empower the next generation of dApps. So our agenda for the day is the following. Um, so why do we need dynamic fields? So dynamic fields exist because there is like some, I want to say, like shortcomings in existing code. So how can we use dynamic fields to uh, like provide how can we use dynamic fields where object wrapping fails? And then we'll talk about the difference between dynamic fields versus dynamic object fields. We'll then talk about composability via dynamic fields. So how we can build composable dApps that supercharge the next era of dApps, and then collections. And then these are essentially just another data structure that are built on top of dynamic fields that can also take your dApps to the next level. So first, let's jump right into it. Why do we need dynamic fields? And then before we talk about that, we need to review what we already have. So let's talk about object wrapping. So this is from the last session, right? When we created that hero in our little game, we saw that if we want our hero to have a sword, it would be like that option there. It would be sword, option, sword, where it essentially says that our hero can either have some sword, meaning it can have a sword, or none sword. It doesn't have a sword. And there are three ways to wrap an object inside of another object. This was just one of them. The other two ways you could wrap an object inside of another object is directly. This is seen on the left, where in the left example, the hero has to have a sword every single time. So when you are initializing a new hero, it has to come with a sword. That's what the one on the left means, or via a vector. So the one on the right says the hero can have multiple swords. And also, I think it's important to keep in mind that when we talk about the option struct, it's essentially just a vector of size less than or equal to 1. If it has 0 fields, if there's 0 objects, it's none. And if there's 1 object, it's some. So these are the ways we can have objects inside of another object. But what is wrong with this approach? So as you saw, when we define this hero object, there are a finite number of fields, right? So for example, we have name, level, HP, XP, the image URL, and the actual sword, right? But what if we're building this game out and we see that maybe, we want to add a shield or we want to add armor or something like that? Because right now we can't equip a shield. So if our game has to evolve, we would have to write that entire like logic from scratch to include the hero to have a shield. Another downside is that an object can become very large if it wraps other objects. And what does that mean? It means that you have to pay higher gas fees in transactions, and there also is an upper bound on object size. It's still to be determined, like the final what that size is, but nevertheless, if an object does get too big, it might just fail in every transaction. Another thing that is wrong with this approach is that we might need to store heterogeneous types. So as we saw, vector only holds a single type T. So in our swords vector, we can only hold other swords. But what if we want to build like an inventory, for example, and this inventory can contain, let's say, swords, shields, potions, etc. These swords, shields, and potions are of different types. They're not of one generic type T. Or like maybe let's say you want to like have like a coin purse, maybe not even for a game, for like a DeFi app, right? You can't store coin A and coin B because they're of different types. So how can we fix this? And then yeah, as you may have guessed, dynamic fields. So let's talk about the difference between dynamic fields and dynamic object fields. So first off, dynamic fields can only be added to another object. And this is evident from the first argument, object colon and mute UID. So a dynamic field name can be any value with the copy, drop, and store abilities. So basically anything that's not an actual object. So like an integer, a boolean, or a string. Or like let's say like a more like a data structure, like an RGB color struct, where it's just a field of the 3 integer values for each color. So dynamic fields cannot store objects. And quiz time. So judging from this function signature, what gives that away? What gives it away that we cannot store objects? And I'll give you guys a hint. It is in the type argument. So if you remember, the type argument is what's in the angled brackets. So the name and value. So I'll go to the chat now. Yes. Hey, you got it. That's pretty quick. So yeah, if you look at the type arguments, you'll see that the name, which is just like a random name, and then the value. Because the value does not have key, it only has store. It means that it cannot store it cannot store objects. It can only store like what I said, like integers, booleans, stuff like that. And then also keep in mind that this API for this dynamic field is a public function, not a public entry function. And we'll talk about why this is important soon. So this was dynamic fields. Now let's talk about dynamic object fields. So again, similarly, it's pretty much the exact same as dynamic fields, but similar to what Aid said, this now does have the key ability, meaning that, of course, yeah, the name of the object we'll be adding can be whatever we want, essentially. And then the value must have key and store. So meaning, since it now has key, it means that it must now be an object. So it like can be an NFT, it can be like that sword in our previous example. It's an object now. So why do we have both? You might be thinking, why do we need to have dynamic object fields and dynamic fields? Can't we just like append whatever we want to another object? So this is actually from Sam Blackshear, the CTO of Miston Labs, who made a forum post on this topic. And I linked this forum post at the end of the slides. And then he said the biggest difference between the two is that when you want to create a dynamic field, it allocates a new object for the field value. So like in the first one for dynamic field, it actually makes that object that we're storing, sorry, it's not an object, but it makes that struct that we're storing an object. Whereas when we use dynamic object fields, it reuses the existing object. What does that mean? So when we reuse the object ID, it means it can still be read by external APIs. So this would be something that's extremely desirable for something like an NFT marketplace, for example, that indexes listings based on their dynamic field, and we still want to find NFTs by their object ID. So if you might be thinking like, I can own this NFT in my wallet, then I can like send that NFT to the marketplace object. Either way, the same unique global identifier will be used to identify the NFT, whether it's in my wallet, whether it's in the marketplace, or whatever. So that's why dynamic object fields are super useful, because you can actually reuse that same object ID. So now let's jump right into writing some code. So in a new terminal, enter Sui move new intro df for intro to dynamic fields. So let's just make a very simple module called intro df, and you'll see that we have three structs. We have a parent struct, the dynamic field child, which only has store, no ID field, and the dynamic object field child, which has key, store, and the ID field. So again, you can see that the second struct, the df child, is not an object, but dof child, dynamic object field, is, because it has key and it has ID as its first field. So this is the API for adding a dynamic field / dynamic field object to a parent. So if we take a look at the first example, add df child, it takes in three arguments: the parent object, a mutable reference to the parent object, I should say, the child object by value, and a simple name, which will pass by a vector of bytes. So yeah, it's as simple as calling the function we saw earlier, field :add, and then the mutable reference to the parent object's ID, the name, which in this case is whatever we want it to be, and then passing in that child object itself. And then same thing for the second one. If we want to add a dynamic object field child, it's pretty much the same exact thing, but we use the O field API instead of the field API. So why do we need to add our own functions? Because as you saw, we created our own objects / structs in this example, but we need to like use a wrapper function. And yeah, I said this earlier, but this is because the field :add and the O field :add functions are only public functions. So we need to have another function wrapping around them. And if we go back to them, yeah, we said that we'll talk about this soon. So yeah, we essentially need to create our own functions because these are just public functions. So now let's talk about actually using these functions and how we can potentially mutate them. So for example, let's take a look at the first and second functions, mutate dof child for dynamic object field and dynamic field respectively. All we have to do this is to just pass in the child directly. And once we do that, we can just we can mutate it like this: child.count equals child.count plus 1. Just increment it by 1. For the third function, mutate df child via parent. So mutate dynamic field child via parent. As you can see, when we're calling this function, we just have to pass in the parent, the actual parent object, and the name, right? We don't call the child directly. We don't need that child directly. So we pass in the parent object and the child name as the vector of bytes, and we just get the dynamic field child like so. So let child equals field :borrow mute. And then for the type arguments, we pass in the name, which was the vector of bytes, and the child, the df child. And then we use for the arguments, it's the parent ID and the child name. So we're able to get the child. And then in the next line, we just increment it again. So that was the third function. Now the fourth function, you'll see mutate dynamic object field child via parent. So similarly, we don't have to pass in the child directly. We just have to pass in the parent object and the name of the child. So you'll see that there's almost like an inner function and this outer function. So let's first examine the inner function. So the inner function is the O field : borrow mute, blah, 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 which retrieves the child object from the parent. So that's what we did like in the previous step. We retrieve that child object from the parent. And then the outer function, mutate dof child, does exactly what it did in the first function. So then once the child is passed in, it mutates the child object. And then time for another quick quiz. Why can mutate dof child be an entry function but not mutate df child? So why can the dynamic object field child be an entry function but not the dynamic field child? I'm looking at the chat now, so I'll give you guys a hint. When you want to mutate something directly, when you want to interact with like an object, for example, directly, you need to actually pass in the object, right? But in the case of dynamic fields, not dynamic object fields, dynamic fields, they are not objects. So they don't exist on the blockchain. So you must call them from another function. If you want it to be an entry function, you must be able to call it from another function. So that was just a quick little example showcasing what we could do. So now let's actually jump into like a more like tangible experience. So make a new module called car and type in the following. So as you can see, we have our same car that we've been talking about since like the first few days of this, right? But instead of having speed, acceleration, and handling as like their own individual values, we just have them as the stats value. But this is important. This is just to show that we can still do this. So we have the car and decal IDs. So in this example, we want to be able to add decals like stickers to our car. But how can we do so if there's no sticker or decal field inside our car object? And then, as you may have guessed, dynamic fields, right? So first, let's actually create our car and decal objects and transfer them to ourselves. So this part is pretty straightforward. We've seen this a bunch of times. We just instantiate these two new objects and we transfer them to ourselves like so. And then to add a decal, it's just as easy as calling the O field add function. So again, all we have to do to call this function is passing in the mutable reference to the car ID. The car in this case is the parent, the decal ID, which in this case is the name. And we're doing this so we don't have to manually create a name. And this is useful if we want to guarantee to have non-conflicting names. For example, if I want to call like one decal like pretty rainbow or like rainbow butterfly or whatever, right? There's a chance that those names may conflict. And if they do, it'll throw an error. But if we just use that object's ID, it'll be guaranteed to be unique every time. And thus it pretty much ensures that we don't have these non-conflicting names. And then we also have to pass in the decal itself by value because we are essentially sending it to the car object. And that's it. So then if we want to retrieve like the decal URL, like we want to like show what it is. So if it's a rainbow, we want to be able to like get the rainbow URL, right? We can do it one of two ways. We can just get the URL directly via the child, meaning we just pass in that child object directly and we just get decal.url like so. Or we pass in the parent, which is the car, in the child name, which is just the decal ID. And then as you can see, it has like that inner function, outer function relationship again, where first we want to call O field borrow, like object field borrow, where we get the actual child, and then we get URL while the outer function is then get URL via child, like so. So we talked about dynamic fields, but they're pretty cool, right? But how can we still utilize dynamic fields to then take composability to the next level? So then it's first important to define what composability is, right? So when I talk about composability, it's being able to use the same objects or the same assets in different dApps. So let's talk about how we can do that with CAPIs. So first, what are CAPIs? So if you go to the website capi.art, you'll see what I'm talking about. Essentially, CAPIs are a developer preview and they demonstrate key capabilities of what you can accomplish with the Sui network. So if you go to this website, you'll see that players can buy, trade, breed, and accessorize capybaras. I've kind of like sound like a broken record at this point, but yeah, they are objects. Everything important, everything meaningful in Sui is an object, and these capis are no different. And like I said, they demonstrate core principles such as asset ownership, transferability, and dynamic object fields. And because they are like an object, they're essentially, if you remember from our last lesson, there's essentially no difference between an object and an NFT. So they appear in a player's wallet like an NFT, along with their accessories, so including hats, bicycles, scarves, whatever. I won't spoil everything, but there's a lot of cool things you can do, such as taking two cappies and breeding them, including a pseudo-random gene mutation. You can buy them and sell them on a market, and so much more. Like I said, I won't spoil it for you, so go ahead to this website after I'm done and find out for yourself. So if we take a look at cappy.move, and all this code is also public on the Miston Labs GitHub repository, you'll see that cappies have two abilities, key and store. So what does this mean? Key means it's an ownable asset, meaning you can own it. It's an object. It appears in your wallet like an NFT. And then it has store, which allows for free transferring and wrapping. And then you'll see the bottom, there's Cappy item, which is also key store, meaning you can do the same things as you can with Cappies. So these are for the types of accessories that we want to add. So as you can see inside Cappy, we don't have a field for Cappy item. So how do Cappies wear or take off the various accessories or Cappy items? And then again, as you may have guessed, via dynamic fields. So also from cappy.move, you'll see that there is a function, there is an API for adding items to our cappies. So like in a future example, like the example we'll go through next, we'll add the car to our cappy. And how can we do that? We just call this cappy :add item function. So as you can see, all it does, the last line of this function, DOF for dynamic object field, add and mute cappy ID, the parent ID, the object :ID, so that's the name. It just takes the object ID, and then it passes in the item itself. And this item can be whatever type T. And then a quick little like Q&A that we'll go through again. What does the T : key plus store say about the T that we're adding? So if you look in the function, the type argument says T : key plus store. It means that it must also be an object. So the child that we're adding to this cappy must also be an object. So now if you want to do that, let's say we want to add this car to our cappy. Let's say we want to create a racing game, right? And in our racing game, we have these different cars, but now we can actually pick which cappy we want to write in it. So in order to do so, let's go back to our first module that we made, car.move, and let's add the store parameter. What does this mean? It means because the car is now a child object, because we're now going to store a car with a cappy, it must have this ability now. So let's go back and add store. And then before we actually write our code, let's go to our move.tuml. So because we're using an external library, we're using the cappy library, we must import the Sui capybara's code. And you can do this super easily. You'll just see that under dependencies, you'll add Sui capybaras, the following GitHub in the subdirectory and what version, and then similarly the cappy address. And that's just OXO for now. So once we've imported Sui capybaras to our move.tuml, let's actually write the function. So as you can see, we have the two uses, we have the two imports in cappy_car. We're using the cappy, sorry, we're using the actual cappy object, right? And we're using the car module that we made in our last, we're using the car object that we made in our last module. So let's say we want to add a dynamic object field of a car to a cappy, or let's say like the cappy rides the car. It's as simple as creating our new function wrapping around the cappy function. So public entry fun ride car, where all we have to pass in is a mutable reference to the parent, which is the cappy, and passing in the car by value. And as you can see, we're done. We just call cappy : add item, and then the parent, which is the cappy, and the child, which is the car. And then you might be wondering, wait, what if I don't want everyone to be able to use my objects? Like, let's say you're creating a game and you don't want people to be able to do this. You don't need to. Yeah, like you don't need to be worried about that. So the only reason we can do this is because the cappy module exposed the add item function for us or anyone to use. So if you're worried about other people doing stuff you don't want them to do with your dApp, you simply just don't give them access. So again, just to reiterate, this is the add item function that the CAPI module exposed for us and anyone to be able to use. So what is the biggest takeaway of all this? I think it's awesome that, again, if we go back, we created a composable dApp in literally one line of code. We just called the CAPI add item function, and we created a composable dApp in one line of code. I don't think you can do this on any other L1 and any other L2 even. That's why I think Sui is just so awesome, because you can use dynamic object fields to take composability really to the next level. So if you're building something, or like let's say another example would be like, let's say you're building like a series of games that take place in the same universe. You can easily have your objects have value in these other games by exposing similar APIs that allow your like sister games to be able to interact with the same items. I think that's awesome. So now let's talk about collections. So dynamic fields essentially extended objects. Dynamic fields breathe new life to objects, but there are still some drawbacks to them. It's still possible to accidentally delete non-drop dynamic fields. And if you may remember, drop essentially means that we can like delete something without the compiler throwing an error. So this is undesirable for on-chain collections that can hold many key value pairs. So collections expose two types of APIs, table and bag. And we'll talk about what this means. So table and bag essentially provide additional support to count the number of entries they contain, and they also protect against accidental deletion when non-empty. So let's talk about table first. So as you can see from the type parameter, again, the phantom k, comma, phantom v, it can only hold store types. And that's shown via phantom v colon store. Only has store types. So again, integers, booleans, stuff like that. So it cannot hold standalone objects, i.e., when the objects are stored as values, they will be hidden when viewed from external storage, such as like a JSON RPC. So again, table is a homogeneous map, and this is shown by the phantom type parameters k and v. It's essentially enforcing that all its keys are of the same type, k, and all its values are of the same type, v. So for example, what this means is that like all keys could be U64s and all values could be like the RGB color struct. So yeah, because the RGB color struct again cannot be an object. And then similarly, we also need and every time we need to instantiate a new table, we need to throw in animute transaction context to instantiate via table double colon new, as it's now an object itself, and it can be transferred, shared, wrapped, unwrapped, just like any other object. So again, tables are storing homogeneous non-objects. So bag is now similar to table, that it can only hold store types. And this is a heterogeneous map, meaning that keys and values can have different types now. So for example, one entry could be a U64 key and an RGB value, and the next value could be a string key and let's say like a balance. It could be anything, right? And just throwing that out there. And the function signature reflects this. Keys now do not all have to be of the same type K, nor do values all have to be of the same type V. But let's say we want to append objects, meaning those that have the key type as well. So now we just use object table and object bag. So again, object table holds homogeneous objects. So like let's say we want to have an NFT marketplace. Let's say we want to like sell our cappies, right? All the keys could be U64s and all the values could be cappies. Or for object bag, for example, let's say we're building like an inventory for our hero, like in a hero game. Let's say in the actual objects, the inventory consists of actual objects. So like swords, shields, potions, armor, we would use object bag. So this is important because similarly to like dynamic object fields, this allows for the objects to still exist within storage, which may be important for external tools, like external APIs that want to read from this. But then otherwise, the difference is not observable from within Move. So to briefly recap objects, if you want a heterogeneous map to store non-object values, you use bag. Just think of, yeah, like a bag of random stuff. If you want a homogeneous map, meaning all the values are the same, but they're still not objects, you use table. And then similarly, if you want them to be objects, you'll use the respective object bag and object table respectively. So thank you so much for joining us today. I know we covered a lot right now. Dynamic fields and dynamic object fields and collections definitely take a while to wrap your head around, but I still think they're super cool. They're super important, and they really are one of the many things that sets Sui apart from other blockchains. So this is a bibliography slash further reading. As you can see, even this bibliography is more bulky, but these are a bunch of links that you should definitely read through yourself. And they provide a bunch of cool tidbits about dynamic object fields and dynamic fields. So before we end this presentation, I'd like to quickly share what we have in store for the next few weeks. For the next workshop will be the actual project showcase, where we'll create our on-chain RPG. So this is not next Wednesday, but it'll be on Monday. I'm traveling to Vietnam on Wednesday, and I think fitting in this workshop while I'm traveling to Vietnam will be a bit of a challenge. So it'll be next Monday, March 13th. And then similarly, yes, we are going to Vietnam. So if you are in the area or you are going to, just be in the area, please do use this link to sign up. Again, there's limited spots, so please register now. And yeah, before I end this, I would also like to remind you guys, as always, there is this survey. Your feedback is super important because it enables us at the Sui Foundation and me personally to know what I'm doing right, what I'm doing wrong. So hopefully I can create more useful presentations to you guys. So with that said, please take the survey and let's answer some questions. I see Tufan asked, for dynamic fields, can we say it keeps a simple hash map for us? Yeah, essentially it hashes the children to the parent. So it keeps a list of every object or just struct that has been added to another object. And then Tufan asked, if dynamic fields are hash maps kinda under the hood, can we retrieve field all without knowing the field names? So like for example, let's say all the values are U64s, for example, right? You would easily be able to iterate through that and retrieve all the values just by incrementing that key. But if it's something like a string, right, we won't be able to iterate through names, right? Zach then asked, can you add dynamic object fields to any objects permissionlessly or only to your own objects? So yeah, maybe you asked this before, but let's just go back to this in case someone did miss it. Yeah, so again, this is from the Cappy module, right? From cappy.move. So the author of this module said, I want anyone be able to add children, like children objects to my parent, my Cappy. Thus, they exposed this add item function, which is a public entry function. Because the dynamic object field :add function itself is not a public entry function, it means not everyone can call it. You can only call this is if you create your own public entry function that wraps around the dynamic object field :add function. So you can decide whether you want anyone to be able to extend these dynamic object fields to your parents. Tufan now asked, we say objects can be shared between dApps, and then in code I see that we somehow use the module code to have it in the use block. If so, how can they be unique? I mean, let's say multiple developers created a car module. How do we know which car is included in our code? Sorry if I'm not clear. No, I totally understand. So like, let's say we were to actually, here in our move.toml, because in our move.toml, our CAPI, our car, because I haven't actually published this yet, right? When I do publish it, it'll have its own unique address. Thus, it'll be guaranteed that, for example, I'm only using like the real CAPIs or like my real cars. So the move.tuml ensures if it's going to be unique or not. Carilio asked, can we somehow use, for example, CAPI contract functions with only providing a deployed address of it to our move.tuml without providing it to dependencies? No, you must do both. Aid asked, so a dynamic object exists independently on chain, unlike when it is wrapped. So yeah, so essentially, if we go back to the dynamic object, like let's look at this car for example, right? This car, which is the parent, and the child, the decal, both can exist as top level objects on the Sui blockchain. So like the decal's ID, unique ID, is going to remain the same. It'll be transferred to the actual car. So it still exists independently as a top level object. Whereas if we go to this example, like we saw in the beginning, yeah, like here, our hero that we talked about 2 weeks ago. Yes, the sword can exist as a top level object because it's an object itself, but when it's wrapped in hero, we cannot retrieve the sword from its ID. We have to first get the hero and then get the sword from the hero. Zach asked, what's the difference between bag and object bag? So if we go to the last, right here. So bag versus object bag. So bags and object bags both hold heterogeneous values, meaning they both hold different types of values. But the biggest difference is that object bag, so in bag you cannot hold objects, whereas in object bag you must hold objects, meaning that the objects that you're appending do exist as top level objects, meaning you don't need to retrieve them from the parent. You can actually just retrieve them directly via the child ID. So yeah, this is the biggest difference between essentially bag, object bag, and table and object table. So then Tufan asked, so if a module is not open source, then can we use it? So composability is only for open source / public, or let's say private and shared to you modules. So yeah, for example, like we saw here in the move.tuml, we actually have to import the code, the library in which we're using it from, right? So if a project is not open source, if we can't see their GitHub, then we can't get it, and we can't use their module. So, and also, even let's say it was open source, if they don't extend a similar API like we did, or like that CAPI did here in add item, if the writer of the module does not give explicit permission for others to be able to permissionlessly use their assets, then we can't do so.
Yep. Thank you so much again, Shayan, for the amazing workshop, as usual. So, yes, next week we are back on the 13th, right?
Yes, that should be next Monday.
Cool. Awesome. And that should also be at the same time. So 5:30 p.m. GMT. We're just switching to Monday, right? Awesome. Thank you, everyone, for coming back to joining us again today as we begin our second half of the Educate series. That's pretty much it from me. I think all the materials that Shayan has mentioned can be found again right in the GitHub. And I hope you guys have a wonderful time exploring how to use dynamic objects. So I think that's pretty much it. Have a wonderful rest of the week. We'll see you next Monday. And Shayan, I hope you travel to Vietnam well.
I hope so. Oh, it's going to be a long flight. I have 2 stops. I'm flying from DC, flying to San Francisco, and then from San Francisco to Tokyo, and then Tokyo to Ho Chi Minh City. So, yeah.
That's quite a journey.
It'll be quite the journey, but it'll be fun. I can't complain. Maybe just a little, but
no, it would be brilliant. Okay, well, thank you everyone again for coming, and I guess we'll end the session there.
yep,
Cool.
sounds good. Bye everyone. See
Right.
you next week.
Bye everyone.